Okay, good evening, everybody. Tonight we thank Netcom Learning for hosting this event. We'd also like to thank the following sponsors. Big Visible has been a sponsor for several years. Turn to Tech, a New York tech school. Pearson Education, providing many of the books we raffle off. O'Reilly Media also sometimes provides books. Auerbach Publishing have provided tonight's door prize. I will now turn this over to Mark, who will introduce our speaker.
Hi. During his over 3 years of decades in the industry, Dan has been solving a variety of management, costing systems, and software problems for both information technology and embedded systems. He has performed all aspects of software development and software management. One of his strengths has been reorganizing troubled software projects. He has created and implemented software management policies. His company, Galorath Incorporated, has developed the SEER applications for cost, schedule, risk analysis, and management decision support. He's one of the principal developers of SEER SEM software evaluation model. Among Mr. Galorath's published works are papers encompassing software costing, modeling, testing theory, software lifecycle error prediction and reduction, and software and systems requirements definition. Dan has been awarded the 2009 Society of Cost Estimation Analysis Lifetime Achievement Award for contributions to the industry and the International Society of Parametric Analysts Freeman Award Lifetime Achievement. Dan is a contributing author of IT Measurement, Advice from the Experts, and Dan is the primary author of the book Software Sizing, Estimation, and Risk Management. When performance is measured, performance improves. His widely read blog, Dan Galorath on Estimating, covers estimation, planning, measurement, control, and risk analysis. This is also the second time Dan has spoken to us. The last time he was here was in June 2008. So let me re-welcome Dan, and I'm looking forward to hearing what you have to say.
Thank you. Good afternoon, everybody. Let me just do the here. It's a pleasure to be here for a number of reasons. I love spins, and I love people that are worried about process and concerned about process and improving things. I also love New York. I grew up in Chicago. I live in Los Angeles, but anytime I get to come to New York, I love it. We're going to talk today about a little bit about process and affordability process, and I'll define it in a second. Affordability decisions will yield project achievements. When people look at things in the most affordable way, projects are generally more successful. Using a repeatable process for affordability is possible, and with some rigor can actually make a major difference in programs. And finally, we can make best value decisions, drive down costs of systems, and drive up return on investment by using affordability. Let's spend a few minutes talking about, here's the 10-step process in a nutshell. I'll go through it in detail. One, identify the things that are critical that you can't change. If it doesn't work, you don't bother with it. We're going to talk about healthcare.gov in a few minutes. And there's an example where they had to have it. Didn't matter how much it cost, China, they had to have it. Step two, identify affordability goals. What are you trying to accomplish? How do you rate them? How do you rate them? Number three, figure out what it is you want to build. Gather the requirements and features and performance, the things you got to have, the things that are nice to have. Some of you are thinking, this guy is clueless. He doesn't understand our job. We got to do all this yesterday. I do understand that. I suggest even a short amount of time spent on affordability process can have big dividends. Look at the alternatives and ground rules and assumptions. Figure out a top-level technical design. For example, if one alternative is built in-house, another alternative is use SAP, that's fine. Figure out what those alternatives are. Do a cost and schedule analysis, my favorite piece, because we do a lot of cost and schedule analysis first. Assess the benefits. Which ones have the most benefits? It could be that the lowest cost one's not the best one. It could be and identify the best value ones based on the figures of merit. We'll talk about those things. Do a risk analysis. This is an area where people forget a lot, is looking at the risks and uncertainty and what happens if things go wrong. Things always go wrong, by the way. Assess alternatives, choose the one that's best. Document how you got there. This is the 10-step process I'm going to talk about today. As I start on this, though, let's talk about Obamacare and healthcare.gov for just a minute, because I think we can use this as sort of an example of some of these things. They had a huge challenge, as you all know. They had six major systems, they had 55 contractors, 3,000 plus different insurance providers that all had to work together. This is a big job. This is a very top level definition of the system, and you can see there's all these different systems that have to communicate with others. Some of these are 50-year-old COBOL programs. None of you have those issues, do you? I assume most of you do. So this was a tough job. Let's get down to some of the things. If you look at what they spent about $300 million in the development. A lot of money, but I'm not saying anybody did anything wrong. I think the press has crucified people. A lot of people have crucified a lot of people. I'm not convinced that people did anything wrong. They certainly spent $300 million. $300 million gets you about 2.7 million hours. So they spent about 2.7 million hours, give or take, on this. It also gets you a system that probably has about 4,900 delivered defects. To build a system that's error-free is impossible. But this is a big, monstrous job. You skip down to, this is the chart I was looking for. This is a diagram of Obamacare. How would you like to have them implement healthcare.gov? 55 different contractors, all these different systems, all these things that had to talk to each other, many of them in COBOL, some of them in Java and other things. But here, make this work. Anybody scared? Wow. It was a complex system. There was a forced deadline. Somebody said, thou shalt have it done. And they had to. Politically, they had to say, thou shalt have it done on October 1st or whatever it was. But it was a death march when it started. Again, they had to do that, make that work on a deadline that was impossible. Now, they had processes. In fact, it's kind of hard to say who was the prime contractor because it wasn't really an overall integrated contractor, but the one that's most like a prime was CMMI level 5, whether you like CMMI or not. They were highly process driven. So just having processes didn't save them. So here's what they had. They had a system that was a death march. The requirements were changing constantly. They had political issues, that one side maybe trying to make the other side look bad, using healthcare.gov as a club, maybe. Other issues that all these different required systems that had to integrate with, and then throw on top of that all state systems. On top of that, requirements kept changing at the top level. We had the very top level people in the government changing the requirements for political reasons, and these poor people had to try to keep up. We all know what's happened. Now, they could have done some things different, but here's in the case. I'm going to talk about affordability today, but Obamacare, healthcare.gov, it didn't really matter how affordable it was. It had to be done, right? And they spent $300 million as a fairly large project. I'm sure you're going to spend many times like that by the time we're done. But this is a case where they just had to get it done. So what an affordability analysis could have done in this case is looked at some of the steps. Maybe they could do it differently. Did this need to be developed from scratch? Could it have been developed as off the shelf? If you look at the number of states that had their own systems and systems that were around, could one of those been modified? I don't know the answers to all these things, but I suggest that many of those things should have and could have been done. Now, if you look at step one of the process, the first one is identify the key performance parameters, KPPs. I'm sure one of them was that it would work for more than 2 people at one time. It's supposed to be a joke. Okay. One of the things that are so significant that if it doesn't work, you can't, give it up, don't do it. Now, again, in Obamacare, they had to do something else. But obviously, some of them were performance requirements. They had to work with X number of people. It had to be secure. There are all these different things that it had to do that it had problems with because they didn't have enough time. Okay, looking at key performance parameters, there's lots of different things that can be key performance parameters. One of the criteria is if the system doesn't do this, would you not do it? And that's one of the great criteria. Is it measurable? Is it testable? Is it viable? Are these things that the customer base, the stakeholders will accept? Lots of different things can happen if you look at systems. One of the problems we have as an industry is we're all optimists for a number of reasons I'll talk about in a few minutes, but look at some of the things that have happened. I gave a talk at the Canadian Cloud Computing Conference, say that 10 times fast, Canadian Cloud Computing Conference. I'm going to make you laugh whether you like it or not. All right, but look at some of the things that have happened. Why am I talking about this with affordability? Because all these things go into factoring. Is the cloud more affordable than on premises? It depends on a lot of things. You know, for example, look at security. There's security questions. From 2007 to 2012, 568 hours of downtime within the 13 major cloud providers, which cost about $72 million. Affordable? I'm not saying cloud's wrong, but it's not a no-brainer. Learning curve, vendor lock-in. We did an analysis and showed how one of the cloud solutions was way more productive. But once you do that, you're stuck. If you want to go somewhere else, you got to do it all over again. Lots of different criteria there. So pick the ones that are the key ones in your case. Obamacare or healthcare.gov. I'm sure one of them would have been security, right? You don't want people scraping social security numbers and all those things. Another would have been some kind of performance. It didn't have to be fast response, but it had to respond. There's several others. Step 2, identify the weighted affordability goals and figures of merit. Now, the key performance parameters are the things, if you can't do it, go home. Do another approach. Affordability or figures of merit are things that are really important, but they're not the life or death kill it if you can't do it. For example, cost might be a figure of merit. We don't want to spend more than X. Response time might be a figure, might not be, might be a figure of merit. Calories in this serving. I just ate one of those pieces of pizza. I'm going to guess that was 600-700 calories. I watch my calories pretty carefully. I blew it. The figure of merit. The only reason I ate that piece of pizza is because I'm in New York and I love New York pizza. But lots of different things, and your systems might be something that might be different. But what are the things that really matter? Maybe not all the things that you're going to have, but for example, more resolution on a digital camera might be better than less resolution, just because it's so better. This comes from NASA, and I know none of you are doing NASA kind of work, but I always thought it was kind of interesting, the things that are key figures of merit for NASA. Number of critical events are bad things in NASA. Complexity, time the crew can be up, et cetera, et cetera, et cetera. In your systems, I'm sure the figures of merit are different. They're probably things regarding response time, reliability, perhaps saving money, return on investment. Cloud's got a lot of them. People are saying it's cloud secure, it's cloud fasting. Is the vendor reliable enough? There's going to be a big fallout in cloud vendors. People that choose the wrong vendor are going to end up out of luck at some point. All these things need to be weighted. If we say that we really want something that's lowest cost, that has high performance, that has ease of use, those three figures of merit, they're probably not all equally weighted. Maybe the cost is more important. Maybe the use is more important. I don't know which one's which, but rate them so you know what the criteria are, which one's most important. Step 3, gather requirements, features, and performance. Again, I know some of you are still thinking, I don't have time for all this. I suggest that you don't have time not to do this. Had the Obamacare people, had the healthcare.gov people been able to do this, and they still had a nightmare, they might have made very different decisions on how to go. I think they went with a home-built system for political reasons. And then maybe could have used an off-the-shelf system and modified it. For requirements, identify what is it you really got to have. What is it that's nice to have? For example, accuracy must be within 1 second. The response time must be within less than 1 second. You go to an ATM machine and you tap on the thing to get your money, and if it takes 5 minutes for your money to come out, it's not viable, right? People think it's broken. Oh, ground rules versus assumptions. A ground rule is something imposed by the client that you can't change. For example, it must work on Windows and Android, might be a ground rule. For example, not on Android, we don't want it. Assumption is something that might be viable, might not. We assume that to work on Android, we have to use, I'm not an Android guy, we have to use some particular compiler. May not be correct, but might be correct. Write these things down. It doesn't take a lot of time to write them down. People go through these analyses in their heads anyway. Just get them written down. If you have a process for getting them written down and documented, you'll be better off. There's lots of data gathering techniques. All the SPIN people, you probably gather more data than anybody, so I won't spend much time on this, but the obvious things, get the data however you can. Questionnaires are always fun. Anybody ever sent questionnaires out? You know what happens, right? Nobody responds. And you have to go out to them and say, hey, what's going on? And work with them on it. Why don't they respond? We can spend 10 minutes talking about why they don't respond, but people don't like to be nailed down. People don't like to say, yeah, this went right, this went wrong, or yeah, I'm gonna be able to do this or that, because they're afraid somebody's gonna come back and hit them over the head with it later. Define the various alternatives and the baseline assumptions. What is it you think you can do? Can we do one, for example, let's use, one alternative, we use Force.com. Force.com is a very productive environment based on the Salesforce platform. It could be a great thing. But are you willing to get tied into that, locked into that? But maybe you are, it's okay. I wasn't saying anything negative, it's a wonderful platform. Whatever those assumptions are that you think make sense, and working these with your team and your stakeholders as well, and systems engineers if you have them. Ground rules and assumptions are key to doing a viable estimate. A viable estimate is key to being able to do affordability. So again, a ground rule is a requirement. You've got to have this. Ground rule, for example, for healthcare.gov, you've got to be secure, right? People aren't going to want to put in their social security number and their whatever else is in there, and then end up getting their identity stolen. Assumptions, we think we can do this with an off-the-shelf system. Write it down. Assumptions are wonderful. I love assumptions. The problem with assumptions is that people make incorrect assumptions many times, and they will. Many times assumptions are going to be incorrect. But then they don't think about the fact that the assumptions are incorrect. They go along with a plan with assumptions that are risky, and things happen. So here's what I suggest is identify all the assumptions, then rank order the assumptions as to how important, how much they'll drive the system cost. For example, in healthcare.gov, if the assumption was that we're going to build this from scratch, we have to assume then that there's going to be a viable operating system, a viable database that can handle this, viable web technology, etc. Identify and rank order the assumptions identify those assumptions that are risky. Again, a lot of people, I've seen people say, well, my estimate just assumed this. And so like they're justifying their estimate. Well, so what? Your estimate assumes something that's stupid. Does that mean the estimate isn't stupid? And I'm not saying, by the way, something that's highly risky is stupid necessarily. But it's important to identify what things in the process, what things that you're doing that may go wrong. Clarify the high-ranking assumptions that are going to cost a lot if they go wrong. Sorry, it says talk about. So you're figuring out how you're going to apply those to cost and schedule. The important part of the process is deal with the assumptions, deal with the ground rules and the assumptions. Perform technical analysis. Now these are probably not the best examples up here, but if you use an object-oriented database, or if you use Oracle or SQL Server, or somebody's trying to sell us now to replace our internet with would they put a dish on and they wirelessly transmit it from building to building, line of sight thing, and I'm going, what happens if it rains? It doesn't rain that often in LA, but what happens if it rains? You got line of sight, I don't know. Anyway, figure out the basic design issues for each of the alternatives. This is work that needs to be done anyway. Do it sooner rather than later. One of the big assumptions people make, and that healthcare.gov did it in some places, is they assume that if it's pre-existing, it's free. Anybody ever assume that? It's pre-existing, it works? I wish I had a little slide here. I don't have it in this deck. But it shows one of the risks, one of my favorite ones. It was a spacecraft and a launch vehicle. So it was a big rocket. It was the Ariane 5, and they assumed that all the software from the Ariane 4 was okay. They didn't need to retest it. Right, and it was in Ada, and back in Ada, in those days, people thought Ada was this wonderful thing, and it solved all the world's problems. Launch happened, thing blew up. It was a software problem. Oops. You can't assume that if something's pre-existing, it's free. And I'm not talking about I think like Oracle or SAP. I'm talking about if you have existing software in-house, and you say, well, just modify this. It needs to be retested. Server, there's a million different things here. These are just a couple examples. Service level. How often is this? How much does this thing got to run? How long can it be down? How competent do the people have to be to use it? I suggested healthcare.gov. It should have been. Maybe I've never tried it, but it should have been easy enough to use it that somebody with a 4th grade education could use it. Right? I mean, just really simple and obvious and neat. So there's a million things you can look at. In this example here, we can see the cost of a service level on different service level agreements. What if you got to keep it running more or less? Things like, what's the cost of support? Yeah, in this alternative here, we're looking at in-house support, and if the people have no skills, it costs a lot. I mean, maybe you can outsource this to India, Philippines, whatever your favorite outsourcing place is. What does it do to the cost of the system? Is it a viable choice? Things like security. Again, looking at healthcare.gov, this is out of our model. You can see in this example here, if there's no security requirements, the thing is 57,000 hours. And this is not healthcare.gov. This is just a particular project, 57,000 hours. You need a really, really serious security. It can go up to almost 400%. If you're building security, that's a tough thing. Now, we saw some analyses on healthcare.gov and some of the things that happened, and part of it was they just weren't done. Somebody analyzed the JavaScript that was getting sent out to people's browsers, and there was like 5 times more JavaScript than there should have been. There were, I think it was four different tools that were being invoked to measure things. They just weren't done. You know the old rule, you get it working and you get it working quick? They just hadn't got time to get it working quick yet. But in some of the security issues, testing security can be a huge nightmare. It can cost twice or 3 or 4 times as much to ensure software secure, or system secure, than to just make the system work. They didn't have the time, they didn't have the thought of it, I think, at the time. They didn't realize, I suppose the developers realized the pickle they were in, but the politics overran them. For the cost and schedule analysis, isn't it interesting? Cost, pick up the New York Times or the LA Times, any newspaper. Cost overruns, cost this, cost that. Everybody cares about cost, but nobody wants to actually spend the time to figure out what it's going to cost. You ever notice that? You know, we got this big system, and here's the requirements, and we need it done in 6 months. How much is it going to cost? Can you tell me tomorrow? Didn't that happen?
As much as you've got.
As much as you got, yeah, as much as you got. That's, why is that? You know, it's partly because we've kind of lost credibility as an industry. People don't believe we're going to tell them a cost that's true anyway. And part of it is a lot of people don't realize you can figure out the costs of software and IT systems up front. And, you know, and I remember one time many years ago when I was a developer, it was a lifetime ago, and my boss, somebody asked my boss when it would be done, and he said, "I'll tell you when we get there." He was dead serious. We don't know when it's going to be done, we'll tell you when we're done. We could do better than that today. Could do better than that back then too, but he didn't want to. Everybody estimates. It's just most people get it wrong. They don't have a process. Isn't that true? Everybody estimates all the time. Your boss, if this happens, when they say, "Hey, we need this thing by next June," they've made an assumption that you get it done by June. Maybe it's a federal law or something, but people are estimating everything all the time. When they bought pizza today, you estimated how much pizza was going to be eaten, right? Didn't? Bought pizza? Okay. What was that example? Having a repeatable estimation process goes along with, in that book they're raffling off covers estimation process. And if you go to my blog, if you're interested in estimation process, there's a million different papers and things on estimation processes. And measurement, estimation and measurement go hand in hand. It's amazing to me how sometimes people don't want to measure the past. They may not know the past, and that's okay, but they don't want to start learning the past so they can estimate the future. I know I'm preaching to the choir here, but absolutely amazing to me how often that's the case. Did you ever notice that a measurement programs usually last about 3 years? You know, the tenure of a CIO, about 3 years. And so a new CIO comes in and they got to do something different. So if there's a measurement program, they kill it. If there isn't one, they start it. And but measuring the history helps us to figure out what might happen in the future. Not perfect, but it sure is helpful. Here's the 10-step process, and I'll put you all to sleep if I go through all 10 steps. This is for estimation process. Basically, it says to figure out why you're estimating, to do a decent job with ground rules and assumptions, things I've already talked about, so you know what it is you're estimating. Estimate, apply risk analysis, and then use that estimate as part of your plan. Pretty simple stuff. But mine's 10 steps. I was talking to Keeper Jones once. His is 7. He said, "Yeah, damn, mine used to be 10, but somebody said 10 was too many, so I made it 7, A, B, and C." You know, that's funny. Okay.
It's estimating, right?
Yeah.
Estimating how many steps you need.
Yeah. Now, what is an estimate? Here's what I believe an estimate is. It's the most knowledgeable statement you can make at a particular point in time regarding cost, schedule, risk, reliability. An estimate is a distribution, a probability distribution. And when somebody asks you for an estimate, they ask you how long it's going to take, how much it's going to cost. They're asking you, not for a probability, right? They're asking you for a point. They're asking you for a commitment. But that commitment becomes a probability plus risk. Now, for example, let's suppose here, this is our 50% probability, or most likely. Suppose it's 6 months. And if you look out here, the 80% probability is 8 months. Well, we know it's somewhere between 6 and 8 months. We might commit to 8 months because there's an 80% probability we can deal with that. But if you don't have a probability associated with your estimate, what does it mean? We've done a lot of studies on people and estimating. And by the way, there's a book by Douglas Hubbard called How to Measure Anything. If you haven't read that book, it's fantastic. It's that should be the Nobel Prize today. How to Measure Anything by Douglas Hubbard. His third revision is coming out in a couple of months, so don't buy it yet. Wait a couple of months and get the new revision. But he's done a lot of work. We've done a lot of work. Other people have done a lot of work in studying estimating and ranges of estimating. One of the interesting things, if you just ask for manual estimates, ask a developer, for example, how long will it take you to do X? And if they say 2 weeks, ask them next, what's the best case to get X done? You want to know what it'll be? 2 weeks. People generally, developers especially, estimate the best case. And you say, okay, what's the likely case? Likely case means some things go wrong, and you get another number. And then those case, what's the worst case? You know, if you've already offended them by showing that their likely case was the best case, the worst case might get ridiculous. You know, but you can work with that and actually can arrange least likely and most, it's viable. From that, you can do risk analysis, and I've got an example of that in a minute, so let me just show you. There's lots of ways to estimate. The number one most widely used method of estimating in the world is, anybody want to guess?
It's guessing.
Well, yes, exactly. Guessing. Number one most widely used estimating, it's not repeatable though. You know, I used to work for a guy who if he'd give estimates all the time. If he liked the person or he was interested in the work, oh yeah, that's easy. We can do that in like 6 weeks. If somebody came in with a really hard thing and he didn't like them or whatever, oh man, that's even if he didn't like them, it was easy. Oh, that's $1 million. The person we thought, you know. So his were kind of manipulative guessing, but anyway. Analogy is a good thing, right? You know, project X cost us X, and so project Y is about 30% more complicated, so it's about 30% more. Lots of other ways to estimate. Expert judgment's always good. Interesting thing about experts, A, they're often biased, and B, they're not consistent either. They don't mean not to be, but we humans are hardwired to be optimists. It's built into us. There's a great article in the Harvard Business Review several years ago. You can find it on my blog if you're interested. On human beings are hardwired to be optimists. I think it goes all the way back to the days when we had to go out hunting and forage and stuff. You know, I tried to catch that or shoot that buffalo or whatever we did. You know, and you missed. You couldn't just say, go home. Right? You had to keep on trying. So it's built into us to be optimistic. And optimism isn't a bad thing. We need to temper that with realism. See, the rest of these are probably not. Of course, I'm here. You know, remember we're the vendors of comprehensive parametric models. So of course I'm pitching that as the best way to do things. Basically, mathematical simulation models that allow you to estimate consistently and have a number of drivers or parameters that you can use. But all these things can work if you're careful. You know, simple cost estimating relationships. If you go out and you collect data in your organization, let's suppose you collected time card data and you knew the effort per program and you rated them a couple of different ways. You could build you could use an Excel, which somebody probably have. You could build a little regression analysis, an equation to say, well, if X happens and Y will probably happen within a range. All better than just guessing. Now, the old price versus cost is always interesting. What are you estimating? Are you estimating what something's going to cost or what the price is going to be? The difference is, any of you ever been to San Francisco? Golden Gate Bridge? You know the big cables they use to hold the bridge together? The big monster cables. There was a contract let some years ago to redo those cables. Cables are getting old. I guess the bridge is 100 years old. So they went out and they got 3 estimates. Estimate 1 was $1 bazillion. Estimate 2 was $1 bazillion-ish. Estimate 3 was way lower. I don't know the exact number, 2/3 of $1 bazillion. Oh man, these people don't understand the problem. You know, how could they be down here and everybody else is up here? So they said, well, before we kick them out, we'll go talk to them. So they said, well, how come you're down here? Everybody else is up here. What's wrong? What are you missing? They said, oh, what you're missing is we have a plan. We're going to take the old cable, we're going to chop it into little tiny pieces, mount it on a board, and say a piece of the Golden Gate Bridge and sell it to the tourists. So we're going to make up all the money we lose in doing the work in profit on the thing. How many of you have one of those? Anybody got one? None of you? Usually there's one person in most groups that have one. I guess 'cause
They did that and they actually sold it.
yeah, they did that. So you want one? I got one. What's my point? When you're doing an estimate, especially if you're a vendor, if you're in-house, maybe cost and price is the same thing. If you're a vendor, you might lower your price because you want that new customer. You might increase your price because you know it's sole source. Of course, none of you would do that. There's lots of reasons to come up with cost versus price. It's important when you're estimating to understand, you're estimating the cost of the price. If you're estimating cost, does it include profit if you're selling it outside? If you're estimating the cost internally, does it include all your overheads and things? Very important. And your answer can be your answer. Whatever you want to do is fine, as long as you write it down and do it consistently and tell other people what it is. Should cost is an interesting concept. What something should cost, not what it will cost, but what it should cost. Will cost says, what can we do if we do good things? Should cost is, what'll it cost if we don't do good things? You know, if we do business as usual, what should it cost? And then what can we do to make it better? Doing that analysis is an incredible part of an affordability process, and many of you are probably doing it. What if we use the latest? We're doing a browser app. We use the latest libraries from who's doing the best libraries these days. We use libraries from X persons instead of doing that ourselves. How much will it lower the cost? What it'll be without it? What it'll be with it? And you've got license agreements perhaps, and the cost can go up or down. But figuring out ways, literally not just doing the baseline, but figuring out ways to reduce costs and schedule is part of the process. It's, I believe, critical. Not just here's a solution. What's the most viable solution? Levi's is a great example of, anybody here work for Levi's? In San Francisco, they probably got the bridge pieces. Anyway, Levi's wanted to do an ERP implementation, so they got a quote for $5 million. It seemed pretty reasonable to them. It was fixed price. Can't lose on fixed price, right? You should laugh at that one. Fixed price can kill you. But anyway, fixed price, low risk, you thought. $5 million, piece of cake. Off it went. They implemented this thing, or started implementing the thing, but they hadn't thought it was other suppliers. Gee, if you've got this new ERP system, I want it to integrate with my system, the one that did the cloth, and the one that did the stitching and the little, all that different stuff. And then the Nordstroms and Macy's and all the people that sold them, that entire system died. It was a complete failure, and the entire Levi's weren't able to ship anything for 3 weeks. Anyway, it cost them $192 million for a $5 million project failure. And I love the failure, the chaos and all that stuff, and the percentage of failures and stuff. And we've done analyses on those, and so basically 22% of the budget of an average IT organization is lost due to failed projects, failed and challenged projects. But it's just the tip of the iceberg. What's the cost to the business? In this case, $5 million. You just look at it from IT costs. We spent $5 million, didn't get any value. $192 million charged against the company. I believe this is analysis that we all should be doing, providing to our management. Some people say, well, that's not our job. Our job is to make stuff happen. Their job is to figure out, these kind of things. We're the people that have the talents, they have the skills, they have the know-how, and the backgrounds to do these. We can help them. And I believe there's lots of things we can do to make IT and process improvement people part of the solution. And this is one of them. Okay, Figures of Mert. I thought I took this chart out. Let's get through this chart. Here's a couple of interesting figures in there. Remember Bill Gates when he said 640K ought to be enough for everybody? In my day, Vietnam era, Norman Schwarzkopf said any general that thinks that he can fight with robots like a Nintendo game is totally wrong. You know what a UAV is? Unmanned aircraft, they're using them all over the place today. And there's a bunch of digital equipment. Remember digital equipment? I used to love the auto increment instruction, auto decrement. I love that assembly language. Of course, they're gone now because one of the reasons Ken Olsen made the decision that nobody ever wanted a home computer. I'm not trying to do that. Anyway, Figures of Mert can be interesting. Again, looking at NASA. NASA figures out where they can get the best bang for the buck using the figures of merit. What a figure of merit means, it might be better off paying 30% more cost to get 50% more functionality. Or to knock 10% of the cost off and lose 30% of the functionality. It's not that obvious just to say the lowest cost is the best thing. Looking again at unmanned aircraft, UAVs, we did an analysis several years ago that showed that rather than building the most efficient UAV, they could get more coverage, they could cover more area for, I forget, even half the cost or something, by building cheaper, not as powerful UAVs and using more of them. And put this into the IT. There's these kind of analyses all the time can go on in IT. Can we use an existing system? Is an average browser okay? What about security? Is there ways we can get around security? Can we do a two-step security? Whatever they are, there's hundreds of ways to solve problems, and having a process where we actually look at these, look at the cost impacts to come up with the most affordable solution is I believe critical. Another cloud example. Cloud has got its goods and got its bads. I'm pretty sure you're all using the cloud now for some things. Sometimes you got to rewrite the stuff for the cloud. Well, there's a huge cost to rewriting. I mean, cloud isn't automatically cheaper. Risk analysis. I've been talking about risk analysis the whole time. Let me just define it a little bit. You know, some people say if you don't know what it is, you can't estimate it. But you don't ever know what it is usually exactly up front, right? And if you know exactly what you have to build when you start, you know, your stakeholders are going to have things they want that you don't know about. They probably haven't thought about it really enough to even know what it is they want yet. I say, if you could tell me the range of what you think it might be, I'd tell you the range of what it would cost. People just using an average. Come on, that's funny. Let me explain why this is funny. 3 feet of water average. Take the average depth of the water here. You know, that's 10 inches, 10 inches, 10 inches, 9 feet. Average all together, it's 3 feet average water. The guy ground. We get in trouble by just giving average numbers, just giving a single point, or estimating a single point, or doing affordability in a single point, because everything is a range. Unless something's all done, that's called accounting, not estimating, or affordability. There's always a range in everything. There's a risk. So people say, oh, agile. We don't need to estimate anything or do affordability, and we'll just do agile, right? And we'll solve all the problems, and we'll do it all. It'll all be wonderful, and we'll just stop when we got all the good stuff, and then life is good, right? I like agile. It probably sounded like I did. I like agile, but there's several wrong assumptions there. A, that you know what it is up front. B, that as you modify it, go through the process, that it isn't going to change. C, that the users aren't going to change their mind. D, that the users will help you at all, so you can really be agile versus being reactive. It's not cheap. It's not free, and it is completely estimatable. You can figure out the minimum time for an agile job. You can figure out the maximum effort, minimum effort. All the same estimating processes can work for agile systems as well. Agile can be less expensive if you stop before you put in that last 10% of the stuff nobody really needs. Agile can take a lot longer because the way the sprints work can make things actually take longer before you actually have a system you can deploy. It depends on the system, it depends on the problem, it depends on the manager. But we can see uncertainty and risk in agile systems. And again, it just amazes me how many people say, oh, you know, we have all these user stories, and we know here's our backlog. We're going to do all these user stories, and I said, but how do you know you got all the user stories? If you're agile, doesn't that mean you're going to be asking people for more stuff? Oh, yeah, I guess so. It's a wonderful process, but it's not the answer to all our problems. And here's part of what happened. Here's what happened exactly in healthcare.gov. The iron triangle. You've got quality in the middle, resources on one edge, schedule on the other edge, and how much stuff, features and functionality on the top edge. As you go through and as you work, you can do things for less schedule. We saw healthcare.gov, right? Cut the schedule, except the quality had to fail because there just wasn't enough. They didn't have enough time. They could have thrown twice as many people in the problem and probably couldn't have got it done either, because there's a minimum time to get a problem like that done. Death marches are caused all the time by people just demanding more functionality, more of this, more of that, fewer people, lower schedule, without looking at the realities of these three issues in the iron triangle. It's always amazing to me when I see, and sometimes you really need it by next June. It doesn't matter what you need it by June. The laws change, and you're a bank, and you got to have some report of something by June. You got to have it. In that case, your schedule's violent. You can't throw too many people at it, but you got to do the most clever things you can to get it done. Without recognizing this iron triangle, though, things fall apart. Same, the bottom one's really the same thing. You can have it faster, you can have it cheaper, you can have it good. Choose to. I swore I pulled this chart out. This is basically just showing typical. If you look at the minimum time to estimate a system, and here we can see the staff aid to get it done in done time. Somebody says, hey, you can have 7 people. Instead of the minimum time where you would have ramped up to about 10, you'll get 7. No problem, right? You can do that. A couple of interesting phenomena. And people don't usually think about this, but if you get 7 people to start, it's productive work. There's extra stuff done. If you were most efficient, you wouldn't need 7 people up front to figure out what was being built, right? To sprint 0, for example, and actual, just kind of figuring out what it is. You don't need that many people. Some work got done. Later on, if you had all the people you needed to get it done in minimum time, you could, but you don't. So all that work's still got to be done, so schedule slips. This is basically Brooks' law, Frederick Brooks' 20-year-old book, maybe more than 20 years old. There's a recent edition, it's absolutely worth reading. Frederick Brooks is the guy that came up with Brooks' law. There's an incremental person when added to a software project, it makes it take longer, not less time. You can't just keep throwing people on projects that make it shorter and shorter and shorter. People were quoting Brooks' law for healthcare.gov, and they might have been right. I don't exactly know if healthcare.gov was staffed to the max. And somebody said, well, Brooks' law wasn't appropriate, and they had some crazy reason, but they forgot the fact that they had a fixed schedule. And but Brooks' law was certainly involved in healthcare.gov. I think some things went right, some things went wrong. They may have had overall too many people or too many contractors. There's not really too many contractors, 55 of them. Again, part of what happens is you add incremental people to a project. 2 people, if just you and I are working, we can just talk together, we go to lunch, we can whatever, solve our problems. We might screw up once in a while, but we can basically get it done. If there's 5 of us, now we got 10 different iterations. If there's 25 of us, 300 different communication paths. And you can't get 25 of us all to lunch very easily, right? You certainly can't all talk together. And that's okay. It's the entropy, lost energy is life, though. Not recognizing that big projects have entropy, are going to be a little bit less productive, is another basic cause of project failure. There's a minimum time to get a software job done. If you ship before that, you're in big trouble. I know you can't read that, but you should be able to read this. And this is out of our model. It says that in this particular system, whatever it was, when you ship it, you probably ship it about the time, the month, I don't know what that is, with 65 delivered defects. You can't ship, if you wait till, if you got 0 defects, you wait until cows come home. You can keep on testing and get them out a little bit, but at some point you need to ship. We say in this one here, ship it about here. So you say, healthcare.gov, let's ship 3 months early. Get me started at 65, but we ship here. 1, 2, 3. 3 months early, 117, almost twice as many. Let's ship 6 months early. Perhaps healthcare.gov will ship 6 months early. 268. Shipping early usually kills systems. 400% more defects if you ship this thing 8 months early. This is healthcare.gov. This is much smaller. Run longer, it's still going to never get to 0 defects. There's an interesting phenomenon in software systems that you can actually track. You can estimate the rate at which defects will be inserted or put into the system. In this case, this is the red line here. The rate at which defects are inserted into the system. The blue line recommends the rate at which defects should be removed from the system. In this case, the green line represents the actual number of defects. So this example, we found more defects. You can argue if that's good or bad, because maybe finding more means you're finding them earlier, that's good. But we fixed fewer. The purplish line is fewer defects fixed. Hence, this problem's in big trouble. We're finding more, we're fixing fewer, this project's in big trouble. It's running, and we're partway through the program, we're not completed, but our metrics could flag projects that are in big trouble early. Without this kind of information, again, I'm preaching to the choir here, hopefully you all are collecting this kind of information, what happens? I used to have a guy working for me, his name was Doug. I wish I could meet Doug again someday. Because Doug was the most optimistic programmer I've ever known. And Doug would come in, every time he found a problem, he'd say, I found the last bug. He really believed he found the last bug every time. He never got it till he found the last bug every day or two. But you know, sometimes, you know, if you're a developer, you either are got to say how stupid you were making the bug, you weren't, or you got to be optimistic, right? So Doug always said, hey, I found the last bug. What happens in systems, right? You're declaring victory. You're agile. You're sprint number 17. Hey, look at it's working. You know, somebody put in a 5 and the range is 1 to 10, and it works. You know, they forgot to try 0 and they forgot to try 11 because they don't have time. In any case, you can track and predict when the project's going to be done based on the defect insertion and removal rates. Oh, we'll just use off-the-shelf. Remember earlier I said maybe you should have went off-the-shelf? We'll just use off-the-shelf software. We'll get rid of healthcare.gov, use off-the-shelf. There were a whole bunch of different systems. California had one, a number of other people had one. Even then, you got to test them, and that's a huge part of the budget, about a third of the effort, just to test them and make sure they do what they should, and more importantly, don't do what they shouldn't. Now, functionality, again, some people say we know what the system is, we got our story points or use cases or whatever you're collecting user stories. Typically, this is out of our model, but you can have about 1.56 to 2.0 times growth in an early concept to actual final project. So typical growth in functionality, if it's not controlled, and maybe it can be almost 2 to 1 from the start time. Well, if you're going to have 2 times as much functionality, you better estimate 2 times as much work, right? The reuse or heritage, again, I thought I talked about this already, but I can say I was jet lagged, but I was in England last week, so I guess this doesn't count. I'm only 5 hours off. Anyway, how much rework do you have to do in existing systems? You better test it again. Skip these couple of charts I put up about these. Risk analysis. Here's something I want to talk about. If anybody read the book, The Black Swan? A great book, isn't it? I love that book. Read that book too. Douglas Hubbard, How to Measure Anything, Black Swan. Black Swan talked about, if you go back to England in, I don't know what year, the 1600s or something, people thought swans were white. And so I guess they said things like, yeah, that'll happen when there's a black swan. Well, then they went to Australia, and guess what? Black swans. Black swans are normal in Australia. So black swan is an event, a risk that nobody thought about. And black swans happen in lots of projects. They're hard to estimate because they're strange things. For example, when the economy crashed, what was it? I guess this was when Bush was going out. It's a black swan. Nobody could have predicted the economy was going to crash for whatever reason it did at the time. But risk is inherent in software and IT systems constantly. And even if you look at if you've got a 90% probability of getting your thing done, and 90% getting your thing done, and 90% getting your thing done, you've got 0.9 times 0.9 times 0.9, less probability of getting the whole thing done. It's less than a 90% probability. Because probabilistically, each of them's only got a 90% probability. And here you can see it's actually a 72% chance, 72.9% chance of getting the 3 of them all done. So risk analysis is a key part of estimation of affordability and project planning. Let's look at risk a little more. Here's a typical system. We went to the developers. We said, hey, how long is it going to take to do 1, 2, 3, etc.? And they said, oh, it's 30, 50, yada, 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 but 500 days. Remember what I said about people giving the best case? And go back and ask them what's the best case. So best case is a little better. Everything goes right. But ask them the worst case is a lot worse. Now, if we use this range here, now we get a range from 452, 500, which is the original estimate if you only used a single point, to 1252. We ran risk analysis, and this is a Monte Carlo simulation. You can do these in Excel, or you can buy tools to do it. Original estimate of 500 days, almost guaranteed to fail. There's about a 1% probability this system could be done in that 500 days, the original 500 days. This is dependent on the risk analysis, the uncertainty. Most likely, it's really 731 days instead of 500 days. And there's a 90% chance it won't be more than 817 days. You may not like the numbers, you might like the answers, but look at the difference we've got between that, which was what most people will do. Single point, add it up, off you go. The visibility of a best case, likely case, worst case, risk analysis, and knowledge. This one's a lot scarier, but a lot more likely to succeed. Obviously, you wouldn't plan 500. How many of you still plan 500 cases? 99% chance you're going to exceed it. Step 9, assess the alternatives. Lots of different ways to assess alternatives. The one with the lowest risk, the one with the highest value, the one with the scored weighting, the best scored weighting. Here's an example of a weighting table. You know, and this is a hard working piece, but high efficiency was 30%, high reliability 25, low maintenance 20, low cost 15, lightweight 10. Then for gears and belts and chains, went through and they rated each of these. They could come up with a value by just multiplying all these things out to find out which ones were the best based on our criteria. Because high efficiency is really important. And this one's got a low efficiency. So by doing this kind of weighting analysis, you've also got something, you know, being a spin people, you got something you can show to management. You know, tell us which of these are wrong. We'll change the weightings.
Something to show the lawyers too,
Yeah. Ooh, dear.
when the loser protests.
Now, you look at software development and IT. Software development's often the biggest risk piece, right? You can go out and you buy hardware,
Right.
and you can buy services people, but software's the biggest risk. If you look at this little pie chart here, this is software. If you factor out about total ownership costs of software development, software maintenance, IT services, IT infrastructure, that's about 6 to 10% of the total ownership costs. So if you're doing if you're looking at a system and an affordability of a system, I recommend looking at it over the life, not just the development. Some people don't care about the life cycle cost, but it's really an important thing. So software is about 6 to 10%. Look at the $300 million spent on healthcare.gov. We do a tiny little quick calculation. If software is 6 to 10%, then healthcare.gov is probably $3 to $4 billion to run that thing. Right, not 300 million, which is still a lot of money. Is that a bad thing? I'm not saying it's bad. Is it too expensive? I'm not saying it's too expensive, but it is what it is. It's on top of all the costs of healthcare, it's $4 billion or whatever to run the system. It's probably a drop in the bucket there. But many people don't look at the total ownership costs of systems. You know, you got the help desk people, and you got the training, and you got the software maintenance and all that stuff. To me, total ownership cost is a key criterion. And in fact, there are some times you've got to have the system. You know, you need ATMs in your bank, you've got to have the software and the hardware system. Sometimes the things are ideas and people are hoping that they'll be good, but they're not. You can kill them before they spend a lot of money. It doesn't help anybody. There you see pretty much the same thing. Same thing. You skip that one. If you look at IT services and IT infrastructure. Oops. There's lots of different stuff that should be considered. The training, service desk, application development, infrastructure, purchase items, like the person that goes around and fixes your BlackBerry or iPhone or whatever it is you're using today. All that stuff should be really part of the cost of the system. Now, you might have people already standing by. It may not be an incremental cost, but all these things I believe should be looked at so you can really have a total ownership cost. Now, some people say, gee, the cloud is so cheap. This is just a little thing I pull off Amazon. I guess.
Yeah, previous slides, something about like platform as a service, software as a service. Comment on anything about
Oh, I have a whole briefing on that. Yeah, software as a service means you don't have to build the software, right? That's great. You may have to configure it, i.e. salesforce.com. The good news is you don't have to develop it. You know, not developing it's usually cheaper. The bad news, for example, we use, how widely is this being shown, this recording?
Well, it'll be up on our website.
We use a major vendor's CRM system, and I won't tell you which one. And we made the analysis ourselves and said, geez, we'll use the cloud version rather than the on-premises version. We won't have to have our IT people maintain it and stuff. And then they make changes, and they'll tell us, and it doesn't work, and then it goes down. And I wish we were on-premises at this point. But I forgot the question you asked.
well, in terms of risk about like platform as a service as opposed to software as a service.
It depends.
And I don't know, I'm not sure what is.
Infrastructure as a service. Infrastructure as a service just says, hey, you go and you spend, instead of buying a data center, you go and you go to whoever, L3, whoever rents stuff, and say, hey, give me 10 servers and give me 300 megabytes or whatever it is you need. And you just buy this stuff, and so it's not in your plant, but it's your stuff. But people do this all the time. Even Amazon, you can go to Amazon saying, I don't want to use any of your software. I just want 2 terabytes of storage. And nice, right? You don't have to maintain it. You don't have to find a place for it. You don't have to worry about power, heat, and all that stuff. I think you've got big problems here like we do in California, right? Probably just keeping all this stuff, all this electricity running. Get it off to wherever the big servers are in Utah or Oregon or where there's no people. So it can be a good thing. It can be a cheaper thing. It can also not be a cheaper thing. It's nothing against the Now, platform as a service is both the infrastructure, the disks and all that stuff and the backup, and it's also some kind of a development environment so you can build something. Again, Force.com. By the way, we don't use Salesforce. I wasn't not saying Salesforce. Oh, 20 seconds or 20 minutes?
Minutes.
Oh, I'm almost done. I thought, because associate here, I thought my score was 20. I thought, boy, so let's see. Software as a service. Give me some. I want this software. It's already there. I can get it by the minute, by the day, by the year. I don't know how. However you want to get it, but it's already there. I want to use it. For example, you could see it on the Azure cloud, our product. I don't have to install it. I don't have to go to my PT people. I don't have to hassle it. Updates are done automatically. No problem. You can also get Seer, a product, on your local servers or even on a desktop. You can do it yourself. There's arguments for both. Which is cheaper? It just depends. It depends on a lot of things. But software as a service. Software as a service. Platform as a service. You can buy. Get something that you develop. Force.com is a great example. Very productive. If you have the right applications. You say, okay, give me some Force.com. I'll build an application on it using the specific language of Force.com. Now you've got the service, you've got the infrastructure, and you've got the platform that's actually running in Force.com. And the infrastructure as a service, Amazon, I need 2 terabytes. Give me some. Each of them has their pluses and their minuses. It's a whole hour talk on it. I have a whole bunch of my blog about it. So speaking of Amazon, this is probably a year old now, but just go out there and it said, oh, this is really cheap. You could save $213.20 or whatever it is using Amazon Cloud. But that's only one piece of it. There's all these assumptions when you get the costs of Amazon's cloud or Microsoft's cloud or Google's cloud or whoever's cloud you like today. Right on premises, servers are going to cost you $25,000, and with Amazon it's only going to cost $13,000. And it's administration. You don't have to have people over there doing backups. What about the person that goes and installs it and makes it work on your iPhone? Does Amazon provide that? No. I don't know people. What about the person that takes it and exports it so you can do local processing in Excel or whatever? No. This is only one piece of the puzzle. Amazon and Google, and they're not doing anything wrong. It's just they're showing where their strengths are. To look and really do a full job and analysis of affordability, you need to look at the total ownership cost. Here's what it's going to cost us for the infrastructure in this case. Here's what it's going to cost us for our internal services and development, all those things. My real point is, just taking the numbers arbitrarily is highly risky. Using an affordability process, you find this might be. I don't know. I really don't know from this which is less expensive. I can't tell. I can hope that the Amazon cloud is less expensive, but there's all these pieces that aren't included here. So lessons learned. Some of the lessons learned is document. And document lessons learned as soon as they happen. So you know what happened. And nobody wants to document. Nobody wants to write lessons learned. Why do you suppose? Well, you like to document. Okay, one person likes to document. One person likes lessons learned. But substantiate, collect information so you can do better next time. Because estimates are never perfect. Even if they're perfect, they'd be called accounting. It's all done. Affordability analyses, the trade-offs. There's a lot of engineering, but there's a lot of assumptions and just hard work in there. Identify missing or complete information. What about the risk that you didn't know would happen? You didn't think about the fact that the cloud vendor bought a business. What are the key decisions made? What are the dynamics that occurred? The things that interactions you had with your stakeholders. Were your stakeholders helpful? Don't write down if they weren't. You got to use code for that. But so really, conclusions. If you look at healthcare.gov or look at any IT system, systems are hard. Requirements can be volatile. Complexity can be dramatic, can be huge. Integration and legacy systems can be a nightmare. Working with 50-year-old COBOL is It's getting harder and harder. Anybody here telling their kids to go take COBOL programming in school? I think I heard the average age of a COBOL programmer is like 74.
Right, but there's 3 trillion lines of COBOL still running around
Exactly,
the world.
exactly. That's the point. Yeah, these guys will be working till they're 90. And but what do we do? You know, how many trillion is it?
About 3.
3 trillion?
From what I hear.
Look at what a SEER estimate and see what the cost of redoing 3 trillion lines of code is, but it's not pretty. Here's some of the lessons learned. The iron triangle rules. You can do things, but you got to recognize if you need more functionality, you need more schedule, more people, or quality goes down. Risk analysis should be an important part of every system. Testing should be important. It should be built into every system. So my 3 bottom line points: viable affordability decisions yield project achievements. You can be more successful with viable affordability process. Process is a key method, a repeatable process, not just, and we think so. Again, I realize I'm talking to the process people, but management above you guys doesn't get this. You know, they think it's a wise, I call it the wise and Johnny coding syndrome. What are we doing all this work for? Like, you know, start programming, start building stuff. You know. We can make the best decisions, driving down costs and increasing value to the organizations by using these processes. That's my last slide. Any questions? Yes.
I can suggest another process area that led to the difficulties which occurred before any of this even happened, which was the basic government decision on the contract strategy for how to acquire the resources to do and the government to manage the work.
Absolutely true. We actually have a whole briefing on healthcare.gov. If you go to that, we'll list that out. There was nobody in charge. There was no prime contractor.
Right.
And that was one of the other risks. It just didn't fit into this briefing. So, but it's fascinating. If you're interested, we've got 2 recorded webinars on our website. I'm not sure, Galorath.com. I don't know how you get there. You must have to register for the library or something. Mm-hmm. I should know this, I guess. And then I know the slides for both of those webinars are on my blog, Galorath.com/WP WordPress. And yeah, we've been keeping up with it on an ongoing basis. It's been quite interesting. CGI, the people that could be arguably the prime contractor, were fired, and they were kind of a sacrificial lamb, I think. So they were not incompetent. In fact, in our healthcare.gov things, it says don't just blame the contractors. Our healthcare.gov brief.
Well, no, in fact, I did a lot of government project management and contract work. And I'm surprised they didn't at least fire the contracting officer, the government contracting officer, because they apparently used a strategy of using an existing IDIQ contract vehicle to throw all this work on it, which meant that you're essentially buying labor hours and pieces parts. You're not buying the skills to manage and integrate the whole damn thing. And when you have a fixed delivery date, you know, and you try and do it that way, you're guaranteed to fail, because everybody will point their fingers at everyone else.
Yeah. And not only that, if you look at it, I absolutely agree. If you look at this at the top level, it didn't look that hard. We've got a partner company we work with. It's a software development company. They said, "Dan, we could have done this for $30 million." There's no way they could have done it. They had no clue the level of complexity beneath this.
Why does something so similar happen in corporate projects? It's not really exclusively government.
Absolutely not exclusively government. That's why I'm talking about it here, because it's a great example. It's got a lot of visibility and one we can talk about. You know, a lot of I can't tell you the Lehigh thing is Levi's published, but I can't tell you the corporate failures that we see most of the time. We talk about healthcare.gov, and everybody's somewhat aware of it. And these problems happen all the time for many of the same reasons. If you go back to the prior slide, you know, lack of leadership, communications falling apart, violating the iron triangle, no risk analysis, not testing the entire system end to end, just blaming the developers or the contractors, and not using commercial off the shelf where you can. These are all things that happen all the time, and different varieties.
I've been on projects where we used something that was off the shelf application. It really wasn't the right tool at all. You really should have been building something from scratch.
That's true.
It saved a lot of money, a lot of time, and turned out staff house.
That's true. Also, that's what affordability analysis might have caught. It might not have. It's not
It wasn't
perfect.
about testing it.
Yeah.
It wasn't actually really tested for what we were using. So,
Plus, on top of that, they might not have picked the right off-the-shelf software for the thing they were trying to solve.
definitely didn't.
That's a problem when the vice president goes out and says, oh, yeah, that's what I want. You know, and then you're stuck.
Yeah.
Yeah, because Joe Jones down the street used it for something else and it worked for him, so it should work for us, yeah.
Yeah, do you find that people tend to equate the concept of affordability with cheapest?
Yeah, that's why it's got to be defined as I did. Yeah, the most affordable isn't necessarily the cheapest. In fact, it's often not the cheapest. You know, look at there's a million examples.
There's a real time value on information, time value of information. Like it would take you in a typical engagement, several months, let's say, to produce an estimate. It might be really great, but if someone else can produce an estimate in a week, a lot of companies might prefer to have less quality of information, but you have that information a lot sooner to make some decision. So how do you, in your approach to this, to providing a service, how do you approach that balance?
Great question. The question essentially was,
Quality.
yeah, the time spent on the estimate versus the quality of the information. The first step in that 10-step estimation process, I didn't want to talk about it too much, was what's the scope? Why are you doing this estimate? A 1 week estimate should have a bigger risk band on it. Hopefully, it obviously can't cover all the details. We could do an estimate in an afternoon. We could do an affordability in an afternoon, but there's going to be a lot more risk, more uncertainty, or both. And it might be okay. That's why I love Douglas Hubbard's book. He talks about reducing the value of reducing uncertainty, spending more time just reducing uncertainty, and the value of that. It's a wonderful book. Yeah, you said you read it.
No,
I do. Yes, sir.
Yeah, what would be your approach to estimating return on investment in software testing, given that testing doesn't produce anything tangible for the business users? And it's a frequent debate between the senior IT management and business, how much to invest in software testing. And business always, demands, okay, show me the money, what is the return on investment in software testing? Or you would rather say, no, the notion of return on investment is not applicable to software testing. It's just something that you need to follow. So what are your thoughts about
Well, remember I had that slide showing the number of defects if you ship early versus if you ship late. We can show the value of testing by looking at the functionality of the system and the ability of it to actually perform its intended function. If you don't test it, what I like to always ask people, and this is on an embedded system, let's suppose we did some new Boeing software for Boeing and put it in the airplane, and we didn't test it. We thought we did a good enough job. Would you get on the plane? Of course, nobody would. Now you could say it's only IT. Sometimes there is no ROI. If it doesn't matter, if it fails, there's no ROI. If it doesn't matter that your developers just kind of slapped it together, there's no ROI. I don't think your developer slapped it together. If you didn't do it, I assume you're doing outside testing. You're doing it in-house, right? And you're probably paying less. I don't know who you're testing, sir, but if you're doing it offshore, you're probably paying less per hour for it. It's probably, I don't know for sure, you'd have to do the analysis. It's probably cheaper to do it offshore than to do it onshore. And it's a disaster to not do it at all. You can look at that chart I have with the number of defects by time and see there's a point where systems just don't work. Healthcare.gov, I think it was 5 times the JavaScript was being sent out. All the unencrypted social security numbers, like 4 or 5 different measurement code stuck in the production system. It was terrible.
Do you do different analysis or when you have resources that are not dedicated to the project? Do you do different probability and risk analysis when you have either dedicated resources or matrixed resources? There's many cases you have in a corporation, you might have a significant number of resources where they're not working on the project 100% of the time. And what I, in affordability, many times business is saying, we want to do this cheaper and faster and better quality, but a lot of times they find the sticky point is the fact that the resources are being pulled in multiple directions. And what I like to show is that the risk goes up when those resources are matrix. And I just want to know if you had come across that, or that was a part of your overall analysis.
Yeah, absolutely. Although but by my definition of matrix, it just means somebody has, she's used the boss, but they're assigned to that program. I think you're saying that they're not full-time equivalents. They're part-time people, which is another whole risk in African models.
They might be being assigned on a
25%.
From a
You get the first 25%, but that guy's bigger in the company, or he's
right. So in a lot of cases, the estimated due dates or the actual due dates go up because you need, every time that person comes back on the project, they need another day to kind of get back into the programming, and so you lose a day every time they come back in. I was wondering if you've ever come across that situation.
Absolutely. Our SEER model actually even has a parameter called resource and support availability, and I don't remember the sensitivity of it, but if you email me, I can tell you the sensitivity. It's 20, 30, 40% difference on the project depending on how available resources are.
If you take that a step farther, you're also talking about, junior people versus senior people.
Mm-hmm.
Okay, you're talking about people that may have not done that type of project before, even though they may be senior, and all that adds up to the risk or decreases from the risk.
Absolutely. Again, my goal here wasn't to sell our models today, but we have experience on the application, experience with the people. All those things are handled by, and you can do it yourself. You can do it in a spreadsheet. You just need to know what numbers to put in. But those are all criteria that should be listed, and risks. I remember my black swan slide. You should have all those risks written down. We're taking the new hires that we just got out of the local junior college for this project. They're paying them half the money, but there's a lot of other risks.
Right. Thank you.
Other questions?
The information that you have on Obamacare, is that all public?
Yes, we only use public information, and we keep it updated. Again, if you go to Galorath.com/WP, the latest stuff is there. And there's a couple of ways we get it. I mean, some of it's just in the public domain, searching the internet. There's a thing called the fact checker, Washington Post's fact checker or something, which is a good source. We've got the sources listed in our slides. So if you're interested in what we did there, you can go to that. We walked a very fine line. We didn't believe that anybody screwed up for us IT-wise. We believed they didn't have enough time. And we were trying to do something that was not prejudiced either way, and that wasn't saying, but just had facts. So it's very fact-based. I don't know that we did that analysis. If I had to guess based on what happened, it's probably 2 more years. But don't quote me on that. Now, you might say there wasn't time because they didn't have a volunteer. What they should have done is they should have scaled back and gotten a kernel of the system sooner. And these people it was a death march.
Yeah, they're all marching in different directions.
Yeah,
55 of them.
That's it. All right, there's a store prize now. I don't know how you did it, but I think I should be entered in it because it's an electronic copy of my book. When the book came out electronically, which was after it was written, I called the publisher and I said, hey, I wanted the Kindle copy. And they said, oh, no, we don't have those. You got to go to Amazon Direct. I wrote Amazon and I said, go buy one. I just didn't have the courage to go buy a copy of my own book. Yeah.
One more time for Dan.